We continue with a series of lectures on carbonyl compounds, and I welcome you all. Recall that previously we went through isomerism within carbonyl compounds. Isomerism within carbonyl compounds, and you were able to quickly go through structural isomerism, and under structural isomerism, we explored that carbonyl compounds can be used to generate chain, position, and functional group isomers. So this is the example which I gave. Then there was also a concern. Don't forget that previously I highlighted that these are not only the isomers that can be generated. We can also have bifunctional group isomers out of the considered molecular formula. Are there. For example, we can also have cyclic compounds. We can have cyclic compounds. Like here for C5H10O. C5H10O, one can also formulate the following example. There are 5 carbon atoms. 5 carbon atoms correspond to cyclopentane. So one can as well have the following. We can have this. This is cyclopentane, and at each corner there is a carbon atom. There is a carbon atom. And also at each corner we have 2 hydrogens. But is this going to give me an isomer which I want? Let me see. Let me explore and see. So at each corner we have a carbon atom and 2 hydrogens, meaning that this is the same as C5H10, C5H10, but I want C5H10 with the O. C5H10 with the O. But if I introduce a double bond here, introduction of a double bond reduces on the number of hydrogen atoms. Yeah, meaning that with a double bond, this C5H10 corresponds to that without a double bond. But if I add on a double bond, this is what I have. There are still 5 carbon atoms, but the hydrogens have reduced. The hydrogens are 1 at each corner. We have at this corner, these are 2 hydrogens here. We have 2 hydrogens there. Also here, 2 hydrogens, those are 4. 2 hydrogens, 6. 2 hydrogens, 8. So this is C5H8 with the O. At this corner, we don't have a hydrogen. We don't have a hydrogen because there are already 4 bonds. We have the double bonds with oxygen, those are 2. Then this bond here, that is 3, and the 4th bond here. So meaning that this corresponds to C5H8O. Therefore, it cannot be corresponded to C5H10O. I think I have to think about another one. I think this cannot work. I can now consider maybe 3 carbon atoms. 3 carbon atoms. For example, this one. Those are 3 carbon atoms, and at each corner there are 2 hydrogens, meaning that this is C3H6. but I want C5H10, C5H10, meaning that I should add on 2 carbon atoms. So I can create a branch here and formulate CH, CH2, and then CHO. How many are those? Here in the triangle, I have 3 carbon atoms. Those are 3 carbon atoms. Then here, considering the branch, there are 5 carbon atoms. There are 3 carbon atoms. This is the 4th one, and that is the 5th one, meaning that those are C5, 5 carbon atoms. Then I concentrate on the hydrogens. Hydrogens, here I have 2. Also here I have 2. Those are how many? Those are 4. Then here I have 1. Those are 5. Then in the chain, 5, 6, 7, 8. There are 8. So this is C5H8O. Still, I don't have a correspondence of C5H10, meaning that that can as well fail to work. I want to generate a cyclic one. That one has refused. Alternatively, I can think about changing the homology. For example, suppose that there are 5 carbon atoms. Maybe I look at a square. Cyclobutane. These are 4 carbon atoms. So we have 4. And at each corner, there are 2 hydrogens. So C4H8. C4H8. Now I want 5 carbon atoms. Maybe I can create a branch. C, now there are 5. And also the hydrogens are supposed to be 10. Maybe I first look at that. So if I have this, then this is 1, 2, 3, 4, 5 carbon atoms. The carbon atoms are 5. Then hydrogens, at this corner I have 2 plus the 2 hydrogens here, those are 4. These are 6. Then here I have 7, 8. Then this is C4H8. I think it is C4H8. Oh, yeah, C4H8. Still, I failed to generate one. Alternatively, no, this is C5. Sorry. This is C5, not C4. Alternatively, I can also have the following. I can have CH3. These are 5 carbon atoms. This is 1, 2, 3, 4, 5. So that is C5. Then hydrogens, these are 2 plus 2, 4, 6, 7, 8, 9, 10. So these are 10 hydrogens. Then I need to add oxygen. So if I want to add on oxygen, what should I do? If I want to add on oxygen, I can create the OH here. Suppose that I create OH there. What do I have now? Let me count them again. So Counting them again, this is the carbon atoms. I start with the carbon atoms. The carbon atoms are 5. If you count them, there are 5 carbon atoms. So this is 1, 2, 3, 4, 5. The carbon atoms are 5. Then the hydrogen atoms, here I have 2 hydrogens. Also here I have 2 hydrogens. Those are 4. Here I have, at this corner, I have 1 hydrogen. Those are 5. At this corner, I have 1 hydrogen. Those are 6. Plus 3, 9. Then plus this hydrogen, 10. So H10 plus see that oxygen there. Meaning that here, I can also generate a cyclic alcohol. I can also generate a cyclic alcohol. So this is the same as CH3OH. And this corresponds to C5H10O. Yeah. So you see, I have created a different homologous series out of C5H10O. Still, we can have other compounds. You can think about compounds with different functional groups. Maybe you think about analkene and the analcohol. Analkene and analcohol. Like here, there are 5 carbon atoms. There are 5 carbon atoms. I hope this is understood. Let me formulate another isomer. So to generate isomers is not a very simple task. It's something which you have to think about. So now I also have to think about bifunctional isomers. Maybe I am just assuming. I also don't know. Yes. Maybe I combine a double bond and OH. Let us see whether I can formulate an isomer. So there are 5 carbon atoms. Maybe CH2 with a double bond. CH2 CH 1, 2, 3, 4. 1, 2, 3, 4. 5. Count the carbon atoms. This is 1, 2, 3, 4, 5. There are 5 carbon atoms. So that is a tick. So C5 is satisfied. Then I look at the hydrogens. These are 2 hydrogens. 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 hydrogens and an oxygen atom. You see, I generate a bifunctional, bifunctional group. Yes, still, it is true. Bifunctional group, a compound with 2 functional groups. The double bond and the hydroxyl functional group. So you see, still C5H10 without information of this isomer. So you can think about also a triple bond and OH. You can as well try out and see whether it comes out. So there are many isomers which you can formulate here. So hopefully out of C6H12O, you've generated some isomers. Yeah, I think I should now take this off and we'll look at something.